Welcome to the Newton tutorial series. I'm Mike Cruz with AC-Tek, and in this tutorial we're going to continue our discussion of analyzing your simulation results, and specifically we're going to talk about creating animations using the AVI Creator. So this AVI Creator window is used to create a series of keyframes that Newton will use to build an animation. In between these keyframes, you can have different camera views, which Newton can smoothly interpolate between. You can also have different layer settings, different particle settings, different clip plane settings, and Newton will keep track of all of that. So, when you want to add a few keyframes, you're going to want to have the SMV window open as well, because all the settings that you're going to be using with the animation, they're all in this SMV window. So the plotting window has nothing to do with our animation. Everything is in between these two windows. Now when we add a keyframe, the first question is, well, which of these settings are saved to the keyframe? And which of these settings are global and apply to the whole animation? And the answer is that the only settings that cannot be changed in between keyframes are the uniform color, the cluster type colors, the outline tolerance, and this rotational center of gravity. Those four items remain fixed for the entire animation, as well as the settings in this window. These settings here, the logo position, the label positions, the colors, they can't be changed in between keyframes either. So if we want to create an animation, well, the first thing we'll do, let's get a nice isometric view and size that properly. Let's make it a little bit lower. Okay. Now a popular thing to do is to do a sweep. You know, when we start out, maybe we want to show a sweep from completely solid to completely transparent. So if we go ahead and add a keyframe at our first view, and then let's go ahead and skip along a little bit to, oh, let's say 1.5 seconds. So after I added that second keyframe, you can go ahead and say, well, I want the second keyframe to be at 2 seconds or 3 seconds. Or I can say I want it to be at 8%, or I want it to be at frame 520, and it'll automatically update all of that. The checkbox here specifies whether this keyframe should be interpolated from the last frame or to the next frame. I forget which one it is. It either interpolates to the last one or the next one. We'll see. So let's make this second frame at 1.5, and when you click on a keyframe, it brings up all those parameters that were associated with that keyframe. So if in this second keyframe, what if I switch to hidden? And we'll say add and update that keyframe. Now when I switch back and forth, we can see that the layer views are getting swapped between those two frames. The same would be true of the particle coloring or the particle style or the clip planes. All those settings are immediately recalled when you swap between keyframes. So important to note, if you want to do this transparency sweep, you cannot have your first frame cannot be set to solid, because in order to sweep that transparency level, it has to be transparent at this frame and transparent at the next. So let's make sure that is set to transparent. Our transparency level is 0. Now on this second frame, let's go ahead and make sure it's set to transparent, and our transparency level is going to be totally opaque. Add. Now, just to see what this looks like, let's go ahead and change the screen size, the resolution for our animation. Let's make this small so it'll create it really fast. And now let's just go ahead and create that animation. And whatever the default name, that's fine. So when you click save, it'll bring up a window in a second here that allows you to choose your video compression, and this will just populate a list of codecs that are available on your computer. And we recommend using the XVID codec. That's why we recommended that you install the XVID codec when you install Newton, because this is the one that we tend to use. It creates a relatively small file size and looks pretty good. So pick your codec, click OK, and while it's creating the animation, Newton will not allow you to do anything in this window. You can't change the size, you can't rotate the model. You can't change any of these keyframe settings. All you can do is close the AVI Creator and open it and push this stop button if you want to cancel that current animation. That's because we used to have it where you could still manipulate the window and you'd end up accidentally bumping the rotation or something goofy, and the animation records exactly what is in the rendering window. So if you click and drag it while it's creating that animation, it's going to screw up the animation. So let's go ahead and find that animation that we just made. If we go there, we can see it saved it right here. So if I run that, you can see that we're sweeping from completely solid to completely transparent over the course of that animation. Now let's put some other parameters into this animation. Let's change that back to 800 by 600 so we can see what we're doing. Now maybe we want to check our particle coloring. What's the velocity? Let's look at steady state. And based on steady state, what do we see as our max particle velocity? It looks like it's maybe a little bit higher than 5 meters per second. So perhaps we want to change that max velocity to 6. Because that'll show us the entire range of velocities. So now let's go ahead and add that and update that keyframe, and we say, oh, what's going on? We've added it here. Oh, and that's because our current time is at 40 seconds. Because I jumped to the end to get an idea of what the entire frame looks like. So if I go back to that other frame, it recalls that last camera view as well as that last velocity scale. So we say, well, okay, what's going on? I don't want this frame. Let's delete that frame. So let's go back to this frame here. Now this frame, I wanted to change this frame to a velocity scale of 0 to 6. So now let's do that and click Update. But we still see that the first frame had a velocity scale of 0 to 5. So there would be a change right when we hit 1.5 seconds. It would instantly jump from 0 to 5 to 0 to 6. So obviously we could go back and we could change this velocity scale to match, either right here or we could change it right here. But a better way to do that, especially if you're trying to copy multiple parameters, is to use this Copy Keyframe button. So you click this button, and based on the current frame, which is frame 2, it allows you to copy all kinds of these different settings to the other keyframes. So I can copy my layer colors, my layer styles, my transparency level, any of my particle settings. I can copy any or all of these scales. I can copy all of the work settings and all the force settings. So those scales and units on those other two tabs could be copied as well as the clip planes. So I specify I just want to copy that velocity scale, and then I say which keyframe do I want to copy it to. Well, it won't let me select keyframe 2 because that's the current keyframe, so we're going to copy it back to 1. Click OK. And so it copied our velocity scale, which is a big waste of time to copy just to one single keyframe. But when you have an animation with 30 keyframes and you realize that, oh crap, I've been using the wrong velocity scale the whole time, well, copy keyframe, velocity scale, all done. And it just makes it a heck of a lot easier to make those changes. Or if you notice that your particle style was lumpy but you wanted to have a mesh simulation, well, you can do the same thing. Copy particle style to all keyframes. Done. And now this one is meshed as well. If we zoom in, you can see that's meshed. So then what if we want to, after our 0 to 1 to 1.5, we want to change our view. We want to look at it. We want to get a side view of this discharge. So after we do this transparency sweep, let's scoot over a few more seconds, and let's immediately swing the camera around over another 1.5 seconds. And let's swing it to this view. Oh, you know what? I'm also noticing this ugly line right here. Let's increase our outline tolerance, get rid of those lines. Cool. Now let's zoom in a bit more, get a good view of this discharge so I can see how is that material going to enter that rock box. So boom, from 1.5 to 3. Because our checkbox is checked, we're going to smoothly interpolate from 1.5 to 3. And we can check this by clicking our quick view. What the quick view will do is it will show the transparency and the camera view throughout the course of this simulation. It's showing you what's happening. So boom, there's our nice smooth interpolation. So now at 3 seconds we say, well, I want to watch, how long does it take to fill up that rock box? It looks like by about 8 seconds it's at steady state, so let's set it to there for 8 seconds. And then what do I want to do after that? After that, am I curious about tracking any specific particles? Do I want to track cluster 1 through the simulation? Or do I want to track, let's also set our transparency level. Fun fact, with your transparent, the transparency of the other particles is determined by the transparency level of the surfaces as well. So that's why when this was completely transparent, all the particles were invisible except for those ones we were looking at. Again, let's turn off our adaptive degradation. But we're not interested in transparent. Maybe we want to see, you know what we might be interested in is at 8 seconds, we might be interested in looking at our fixed Z. We might want to see, well, how does the material flow out of this section of the rock box once it's built up? So if I know that my minimum and my maximum should be -2.2 to -0.5, that's going to give me a range from here to here, maybe 0.4. And we want 7 slices. So now we have a nice little visual of the material in the rock box. And if we allow this to play back, or if we skip forward a bit, well, before we skip forward, let's save that keyframe data. Now let's skip forward to 8.5, or 9, or 10. So that's what that animation is going to show us. It's going to show us that these couple of slices down here are not really moving. At least not right up against this front wall. And that brings up another point. Well, when I look at this, let's go ahead and reset that data. When I look at this, I don't know, am I looking at the flow right through the center of this flow, or am I only looking at what's happening right on the front surface of this chute? How do I know what's actually happening in the middle there? And the answer is, well, set up a clip plane. So what you would do is, let's say, go back to that frame 8. And we don't want to lose this camera view. We know that this camera view is correct. So when you go from keyframe 3 to keyframe 8, oh, actually that's a different camera view, isn't it? So let's match that camera view. Let's go ahead, go to our keyframe 3. We'll say set view 1. Now when we jump to keyframe 8, we can recall view 1. Update the keyframe, and now we have the exact same camera view. Now, we want to set up a clip plane. So let's go ahead and temporarily just hide the particles and set up this clip plane. We want to hide the data, just the particles, in the box that we designate. So let's set that from -5 to 5, -5 to 5, -5 to 5, and show those clip planes. Alright, clearly the box is way too big. But let's fine-tune those parameters in the y direction. -4, -3, -2.5 to 2.5. That's good enough. In the x direction, well, we know that our origin is right at the center of the head pulley, so to slice through the middle, let's just leave the minimum x at 0. But wait a minute, we know that we're looking at the view from this side, so we want to make sure we're slicing off the proper half of this chute. So we want to leave the maximum at 0 and set the minimum at -1. And that's going to slice right through all that data in that upper chute. But to not confuse ourselves about the material right here, maybe we just want to slice off all the data up to -20. So now we're only going to be seeing the data that's on this half of the chute. So hide that clip plane, go ahead and show our particles again, and we're only seeing the particles that are outside that clip plane. So now if I again recall that view 1 and I go and update, now we have a clip plane set up for this keyframe. So if I jump forward in time 8.5, 9, 9.5, well, our original assertion was correct that the material down in this corner is not really moving that much. However, we know that now we're taking a slice, center slice, right through the center of the chute, so we know that we're looking at the center of the flow. Then, after we do this, let's make sure that our keyframe goes for how many seconds? Oh, doesn't need to be that long. 2 seconds, that's fine. From 8 to 10. At 10 seconds, what do we want to do now? Let's look at some position tracer view. Let's go back to a velocity coloring and look at position tracers. So recall that the position tracers are taken directly from what's currently visible. So once I click position tracers, I can't see any tracers yet because we haven't allowed Newton to generate some data yet. So when I switch from anything to position tracers, it's always empty. I have to play back a few frames to get that data. Now let's go back from 8 to 10. At 10, we want position tracers to turn on with this velocity. Update the keyframe. So let's just look at position tracers for maybe 2 seconds. So from 10 to 12, we're going to have position tracers. And when I'm skipping around in these frames, like I said, you can't see any of the position tracer data because that data gets reset when you skip around in the keyframes. But rest assured that when you run the animation, it's going to show that position tracer data. So at 12, we're going to swing around to a front view over another 1.5 second interval. We're just going to do a straight rotation, boom, like that. And I'm trying to line up this rotation perfectly to get a perfect front view. But you know what? What am I even thinking? Let's go back to that last view, turn on our advanced orbit commands, and say, I want to rotate about this vertical axis. So let's say 90 degrees that way. Done. Don't have to line it up, don't have to waste my time trying to get that perfectly lined up. Now if we skip a few frames, we see, oh, hey, this is curious. Our clip plane was still on. Did we want that clip plane on some more, or did we not want it on? Well, let's update that keyframe. And we notice, oh, wait a minute. Whoop, we skipped forward a few frames. So let's just delete this keyframe. Go here, modify that, change that back to 13.5. So now the question was, at this last keyframe, at keyframe 12, we had this clip plane on, which I guess it makes sense if we're looking at the data in the rock box. But then we swing around to the front view, do we still want to have that on, or do we want to turn that off? I'd say, let's go ahead and turn that off, because otherwise we can't see any of this discharge. So again, we'll reselect our keyframe 13, or keyframe 7 rather. Go to our clip plane and say off. We don't need to delete the values, we can just leave that there in case we want it later. We can just shut it off. Now if I skip forward, we're seeing all that data again. And that's what that will look like. So, from that keyframe, how far do we want this to stretch out? Maybe we want to, well, when we swing around to the front view, right now we're only looking at the front discharge again. So maybe as soon as we swing around from the side view to the front view, maybe right after that we want to expand out over another 1 second. And zoom out and shift downward. Let's zoom back in a little bit. There, just like that. Update that keyframe. So at 12, from 12 to 13.5, we're going to swing to a front view. And then right as soon as we get to that front view, we're going to move downward and zoom out to this whole discharge view. And then what we would be seeing here is our position tracers. Now, perhaps we also want to include a little bit of transparency. Maybe with these position tracers, we're not quite sure. Well, I think this is the skirt that I'm looking at right here, but is that correct, or is that the shoot? What am I looking at? Let's go ahead and turn on some of these surfaces. So solid skirt, yep, there's my skirt right there. Maybe I want to turn this transparency level back up. Maybe just a little bit. Let's turn on to whatever, right there, that looks good. So let's add that keyframe, and oops, yet again, I screwed it up and called that 14.59 because I was moving through the keyframes while I was generating my position tracers. So let's delete this keyframe. Go back to this one. Change it to 14.5. And now that keyframe will be ready to go. And what we'll notice is that from 13.5 to 14.5 there will be interpolation. So we're going to interpolate from completely transparent to 20% opaque or 80% transparent over this 1 second interval. If we don't want to do that, then we can go ahead and uncheck this interpolation box. I believe it's this one. Since this is the keyframe that leads into this keyframe, you want to uncheck that interpolate box. And I'll confirm that here in a moment. Actually, we can confirm it right now. Let's click Quick View, and let's just watch this one more time. So from 0 to 1.5, we're doing a complete transparency sweep. Then we switch to this side view, and now we'll be looking at our fixed Z position. And as soon as we hit 8, we should be switching, what did we switch to? Position tracers, I think. And then at 12, from 12 to 13.5, we switch over. Ooh, and it looks like something was not quite right. Oh, maybe it was right. At 14.5, we don't have any time. If we instantly snap from 13.5 to 14.5, or rather, if we instantly snap at 14.5, if we instantly snap from this view to that view, there's no time at the end of this animation. Once we get to this view, the animation stops. So let's just put another 17. Let's put some more time there. Do another quick view. Oops, not create AVI. We want quick view. Anytime. There we go. So we do our sweep, swing around. From 3 to 8, we're just looking at our side view of our velocity again. At 8, we switch to that fixed view from 8 to 10. And then at 10, we switch to our position tracers. And at 12, we swing around over 1.5 seconds to 13. And then at 14.5, we instantly snapped to this new view. So we didn't, from this view to this view, we did not do a smooth interpolation. I forgot to mention that. So the interpolation applies to both the transparency as well as the camera view. So because we at least want that interpolation to apply for the camera view, we're going to turn that back on. So now it will translate smoothly from this frame to that frame. And then the simulation, the animation will end at 17 seconds. So maybe we want to we probably want to include a short analysis on, say, the work. We want to look at the work on that back plate. So let's go ahead and to make this a little shorter, let's just delete some of these keyframes. Actually, no, we'll skip that. So from 13.5 to 14.5, we move here. And actually, let's just get rid of these last 2 keyframes and say that from 12 to 13, and then from 13 to 15, we'll just swing around to a front view. Let's look at a front, that's a back view. Let's look at this front view here. And let's also change our back plate to work. And now we want to make sure that our particles, do we want our particles to be visible? Right now we're in position tracer mode. So as the simulation is going, this is what we would see. We would see these particles covering up that wear plate. So we got to make sure that we change that to hidden. so that we're only seeing the wear on that surface. Now when I click Add Update, of course, yet again, we've skipped a few frames and now we're out of sync, so let's delete that frame and change this one to 15. So, from 13.5 to 15, we'll swing around to a front view, and then right at 15, we will disable our particles, and we will change the backplate so that we're viewing the work. And let's say we want to view the work for 3 seconds. 18. Now when I skip between keyframes, recall that we're not actually recording the wear data from 15 to 18. I can't actually see what that would look like. So what I want to do is I want to open up the SMV window, the Work tab, and I want to do a quick work summary from 15 to 18 and say, well, what am I going to see in that animation? And it'll generate a summary. And you'll notice that our scale keeps changing because it's adjusting itself with the maximum work value. But we probably don't want it to do that because we want to be able to see this work progression. So once this finishes, we'll get an idea of what's our maximum value. And it looks like our max value is going to be about 0.15. So even right now I could go in here and say, well, I want that to be 0.05. And that's what I want to see. Or even 0.04. So if I regenerate that summary, again, because this is averaged over area and time, the data doesn't necessarily increase in value, it simply averages itself. If I was looking at my work units in joules, then we'd start off with basically nothing, and we would watch it start to appear on the backplate because we're simply adding up all those values. But because this isn't a time averaged and triangle average data, it looks different. It just starts off being all scattered and then eventually works itself into a nice pattern. So that's what we would see right there. Now our triangle forces, or we won't look at the triangle forces right now. So from 15 to 18, we got to make sure that we set the scale at 15. What had we said? We said the triangle impact, we want the max to be 0.04. 5 divisions, well, this looks goofy. 0, 1, 2, 2, 3, 4. Well, let's change that to 4 divisions. That looks nice. Now we'll go ahead and update our keyframe. And the period of time from 15 to 18 is going to be using the scale that is at keyframe 15 or keyframe 8. It's going to be using the scale from this frame. Once we get to 18, it would go back and be using the scale at 18. So during this 3-second period, we got to make sure we set the scale parameters for this keyframe, not for this one. And maybe at 18 seconds we want to change and look at the triangle abrasion. So let's go back again and say, well, from say 18 to 21 seconds, what does our triangle abrasion summary look like? And again, it's changing itself constantly, and we don't want to see that. So we'll pick a maximum of 1.5. Okay, that's close enough. So now go back to this frame 18 and make sure I set those values. Change it to abrasion, change our max value of 1.5, and the number of divisions, that can have 5 division. That looks good. 18. Now I want this to go from 18 to 21 with the same view and the same settings. So 3 seconds of impact wear and then 3 seconds of abrasive wear. And after that, why don't we swing around to a top view and look at the triangle forces on that receiving belt like we did in the last tutorial. So at 21, now over a 1.5, so 22.5, switch to a top view, rotate here, look at this, turn off the work, but change that back to transparent, change my receiving belt to force. And like we mentioned in the tutorial, it's easiest to visualize these perpendicular forces if we have the belt going up. So let's actually rotate it this way. Okay, now our velocity is going upward. Update. But now the question is, what do we want to happen in this 1.5 seconds while we're sweeping from the front view to the top view? What's going to happen right now is this is still set to triangle abrasive wear. So during the whole time that this is swinging upward, we're going to be still looking at the abrasive wear on that plate. But maybe that's not what we want to do. Maybe if we're going to swing from this front view to a top view, we might want to let the user know that, hey, the material on this receiving belt is moving in this direction. Because when we get to a top view, again, we don't want to be showing the particles. Because if we're showing the particles, we can't see what's going on with the receiving belt. But we want the user to remember that the material is moving in this direction. So maybe from 21 to 22.5, we'll turn off that work, show our particles, and color them by velocity again. Because then for that 1.5 second, we'll do a nice spin up and spin around. And we'll say, oh yeah, that's right, the particle is moving up, particles are moving up there. And you know what we should also do is once we get to this top view, once we get to the top view, rather than switching to view of the forces right away, let's give them 1.5 seconds to just look at the velocity of the material on the belt. So right here at 22.5, let's change this. We're not looking at the force yet. We're looking at the particles with the particle velocity. Or we could even leave the force on. It doesn't matter. Oops. You won't be able to see the forces, but the point is you can see the material on the belt for a few seconds. So now we'll swing upward, and then at 24 seconds, now we will hide the material. So now we'll be looking at those forces. So if we go to that tab again, we want to generate a force summary from, say, 24 seconds to 27 seconds. Let's look at that. And we say, oh, I can't really tell what's going on. You know what? I don't care about the perpendicular. I just want to look at the parallel. I'm interested in the acceleration, the loading on the belt by accelerating the material. So if I generate that summary, you can't really see much because this is flipping around too quickly. So let's force this to go from 3 to -3. 2 to -2. That looks good. I think the value for the exponential filter is acceptable. And maybe I want to zoom in on this a bit. Zoom in that camera view. There we go. If I click update, again, we're on the wrong keyframe. So let's just delete that old one, rename this one 24. But now, again, we have two different views between 22.5 and 24, because on this keyframe, I just decided to change that camera view. Well, like we did before, we can go ahead and save this view, top, go back to our keyframe 11, and recall top, update. Now we have that same view between the two of them. So from 21 to 22.5, we sweep upward, and then from 22.5 to 24, we are looking at the particles moving on the belt. But recall that at 24, that's when these particles actually turn off. So from 24 to 27, we probably want to just be observing those belt forces. So if I play back, you can see, yep, that's what we're going to see about from 24 to 27. And as I noted at the beginning of this video, all of these forces, these scale forces, the decision to show parallel or perpendicular, the filtering settings, the rendering mode, all of that is saved with each keyframe. Same with this on the work tab, all of that is saved. So in between these keyframes, I could be showing different work types, I could be showing particle work, I could be changing the scales at different keyframes, and all of that would change with the keyframes. You know what? Why don't I have a total work label as well? That's what I should do. So at 24, we want to look at the total work on this layer. And where is that total work label? Why don't I see that total work label? That is a good question. Oh, because we're not looking at work. I'm in the work tab, but I'm looking at force right now. So of course it's not going to show the work label, but it would show the force label. There we go. And I don't like the position of that force label, so I'm going to go up here and change it. So where's my work? I believe the work and the force actually share this same label. So if I change this to 94, yeah, 95. So these text boxes right here are for positioning all of these different labels that you could show. The time label, the horizontal and vertical position denote the movement of the top left corner of this label relative to this top left corner of the rendering window. So a value of 1, 1 means we're 1% down, or rather 1% over and 1% down. If I was to move this down to 1, well, just look at the work label. The vertical is 95%. If I was to change this to 99%, recall that we're talking about the top left corner. So the top left corner at 99% is at that 99% mark, but the rest of the label is off the screen. We don't want to do that. So, 95 is the maximum for this particular resolution, or maybe 96. There we go. And of course, we don't want it to be for this keyframe. We want it to be for this keyframe. So let's go back into our settings for this keyframe and turn on that force label. And recall that all of these settings are global for the entire simulation, so you can't be changing the location of that label between different keyframes. It's going to be the same for all of them. So from 24 to 27, we're going to be showing that label. And then at 27, let's go ahead and, you know what, it's about time to end this animation. So why don't we swing back to our initial animation view. So go back to this keyframe, save this current view. So this is our, say, ISO 1. Now I go back to here, and we know that from 27 to, well, let's give it 1.5 seconds again. So from 27 to 28.5, we're going to swing back to this isometric view. We also don't want to be looking at the layer force when we get to this view. When we get to this view, we want to be looking at our initial view again. Turn that off. We want to be looking at the particles again. Let's look at the particles as meshed. Add an update. So from 27 to 28.5, during that transition period, we're still going to be seeing these forces, right? As we're swinging up here, it's not until we get to 28.5 that we actually change our view settings to look at the particles and to turn off that force. So in the region from 27 to 28.5, well, you know what, it's good enough for now. We'll just leave it so that we'll be seeing those forces as we swing up and interpolate our camera view. So from 28.5 to 30 seconds, so hit it on the mark. We'll just do another 1.5 seconds of steady state flow at the end. No, let's go to 32. So 3.5 seconds of steady state flow at the end. So if we want, we could do a really quick view through the animation, but we don't want to waste our time doing that. So before I create this animation, I'm just going to discuss these other couple of options on the keyframe window. So we can open and save this keyframe file, all these keyframes. Obviously, if we're looking at multiple revisions of the same, transfer point, maybe we're looking at different backplates or different rock boxes, we don't want to set up this whole dang animation over and over. So we're going to go ahead and save this keyframe as my AVI. So that keyframe file just saves all the data for each of these keyframes. Create AVI is going to create that animation. Quick view, we already showed, that's just going to look at the camera view as well as the transparency interpolation. Resync times, what this does is if you open up a keyframe file while you're looking at an animation that let me start over. If you have a keyframe file, like we made this keyframe file right here, and then let's say I go and open up another one of these simulations, but that simulation, rather than going out to 40 seconds, maybe that simulation went out to 60 seconds instead. But perhaps I want to keep the same ratio of all these keyframes so that I start at time 0 and I end at 32 divided by 40 would be 80%. So maybe I want the animation to still take up 80% of that 60 seconds. If I open up the animation and hit resync times, it'll look at the percentages for all these keyframes and it will adjust the times and the frame numbers accordingly. So it would stretch out that animation. Or if I open up a smaller animation, it would shorten that animation so that it still remains within those original bounds. A time shift is simple. All it does is shift all of the keyframes up or down by the specified amount. Since my frame rate here is 100 frames per second, the smallest I could time shift by is 0.01. If I try to do any smaller, it probably just won't shift at all. Exactly. If I try to time shift by 0.015, it would either shift by 0.01 or 0.02. Nope, shifts by just 0.01. Anyway, but the point is that's just quickly, if I want to shift these all down by 10 seconds or 12 seconds, I can quickly do that. So let's shift it back up by -12. And then -0.01. Bring this back to where it was. Oh, and it looks like somehow when we were doing our 0.015, some of these animations got off by just a little bit. Okay. So, as I mentioned before, we have our screen size here. What's the resolution we want for this animation? And the nice thing is, as you change the screen size, let's say we made this whole set of keyframes with the 800 by 600 resolution. But if I wanted this animation to instead be 1280 by 1024, all of your camera views and everything gets scaled properly, so that you're still going to have pretty much the same view that you did before. You don't have to worry about the camera view being incorrect. So I think we're going to do this at 1024 by 768. The frame rate is how many frames per second you want the output animation to have. So if we wanted to figure out how fast is our animation going to play, well, we need to know what's our frame rate and how many frames per second are we recording. We know that we have 100 frames per second of data, and if our output animation is 20 frames per second, well, obviously 20 frames per second would take 5 seconds to display one complete frame of data. So it'd be about 20% playback speed. If I wanted to speed up my animation, I could include frame skipping. So if I set frame skipping to 1, it means that we are going to skip every other frame. If I set frame skipping to 2, it means we are going to record 1 frame and then skip 2. Record 1 and skip 2. If I set it to 3, it means we record 1 frame, then we skip 3. We record 1 and skip 3. However, if you'll recall from my last tutorial, or possibly the tutorial before that, you cannot use frame skipping if you intend to display work results in your animation, because the work is encoded on a per frame basis. So if we have frame skipping, we're missing some of that work data. So we can't do any of that. The only way we could speed it up is by increasing the frame rate. So we'll make that 40 frames per second. And if we want, we can turn on the little label to show the current particle count, and we can set the position for that as well. So we want to make sure that's not overlapping though with our label right here. Because our label right here, where is that label? I thought I had turned that on. Oh, there it is. It's on 24. So we can see these labels are overlapping. Let's just shift this one up to 94, 93. You know what? Let's move it right below the time label. 5, 4. There. So now we know the total number of clusters and the total number of particles in the simulation at any time. Sign interpolation, that dictates how you want the camera to interpolate in between these keyframes. Because by default, the camera will simply do a linear interpolation from this view to that view. But if you notice, when you're switching your views using these buttons, the speed of the camera follows a sine function. So right when you click the button, it starts out moving slow, and when you're in the middle of that camera sweep, it speeds up, and then it ends. It slows down as it ends as well. So that just looks a little bit cleaner, and I think that's what they do in AutoCAD as well. And if you want, you can apply that to your animation as well, rather than just doing a straight linear interpolation between the camera views. We already talked about the copy keyframe window. That's how you use to copy the data between different keyframes. Label positions, we've talked a bit about that. Your time label position, your main comment. If you wanted, you could have a main comment describing what this is. So we could say sample animation, 40 frames per second, blah blah blah. And we can see that that label is overlapping with our particle count label. So that's our main comment label. Let's move it down. Move it down one more. There we go. Now it's out of the way. Sub-comment label. For each of these keyframes, you can have a custom sub-comment that gets displayed somewhere in on the screen. So if right here when I'm looking at the where, maybe I want to say this is the triangle impact where. Of course, it's already listed right there. It's telling me what that is. But if I wanted to have, just for an example, this sub-comment label, let's just move it down halfway down. Triangle impact where, triangle abrasive where. And right here, we want to say triangle parallel force. So these sub-comments will only be displayed for the keyframes that they're attached to. So from 18 to 21, we would see this label. From 15 to 18, we would see this label. The logo position is just the position of the AC-Tek label. You can turn it off if you want. You can put it in any of these corners here. We're also working on implementing the ability for users to import their own company label to display on the animation. The colors here are, this is the color for all of these labels. I could change it to blue if I want. Make it a darker blue. The background color is the same as the color for the, it's the same as this background color right here. However, this background color just gets saved with the specific keyframes file. If I wanted to make that pink, which I absolutely do not. And I think that pretty much covers everything in here. So let's go ahead and save this keyframes file one more time. Always want to save the keyframes file constantly, because if Newton crashes or if you end up closing it when you weren't thinking, you don't want to lose all the work you put into making this animation. So I'm going to go ahead and create this animation and pause the video for a moment, and when this is finished, I'll come back and we'll watch the animation. Alright, so we finished that animation, and I changed the resolution from 1024 by 768 back down to 800 by 600 so that it would create that animation a little bit quicker. But here's the resulting animation. So we do our sweep to the side. Got 5 seconds of flow just looking at a side view of this rock box. And then we'll switch to that fixed Z at 8 seconds. We'll do this for 2 seconds, then switch right to position tracers. At 12, we swing over to a front view, and then immediately swing back to look at our wear on that back plate. 3 seconds, you'll notice we see the progression of the wear summary. But now when we switch to our abrasive wear, the summary is already complete, because over that first 3 seconds it was creating this summary as well. At 21, we flip up to the top view, We provide a second and a half of flow so that the user knows the direction of the particles. And then we switch to our parallel force. At 27 seconds, we swing back to our original isometric view and switch to our meshed velocity to end out the video. So this entire animation was about 50 megabytes with that codec. If we would have used a 1024 by 768, the file size would have been larger and it would have taken longer to render. A quick little handy reference is if you go to the animations section of the Newton manual. If I can find the right page, right here is your comparison of your relative file sizes based on the resolution. So the resolution obviously directly ties into the number of pixels in the resulting animation, and based purely on the number of pixels we can compute an approximate relative file size. So based on our base 640 by 480 resolution, if you upgrade to a 1280 by 1024, you're looking at a file size that's going to be over 4 times larger. And that's simply looking at the physical area of the rendering window. And similarly, we have some similar numbers for the 16 by 9 resolution. So I think that about covers it for creating animations. There is plenty of good information in the Newton manual as well, but if you have any other questions about making animations that you can't find the information for, go ahead and send us an email at info@actek.com. Thanks.